Okay, so we got problem 7.68. There is no energy stored in the circuit at the time the switch is closed. And our first question here is going to be find I naught t for t greater or equal than 0. So we can go ahead and analyze the circuit before we go ahead and do anything. And yeah, let's set this node as our ground node. We got this as 80 volts. We know since no energy is stored in the circuit that I naught at time before 0 is going to be 0, right? So yeah, let's go ahead and yeah. Let's not t. Okay. For t greater or equal than 0. Okay, so we got our KCL. I naught equals I1 plus I2. And our equation for components, we got I naught t equals to 80 minus v naught t over 20. Then we also got v naught t is equal to 5 di1 t over dt minus 10 minus 5 di2 t over dt. V naught t is also equal to 10 di2 t over dt minus 5 di1 t over dt. Okay, so now that we have these equations, or the circuit analysis, we've done the circuit analysis. We have 4 equations. Let me just write down. We got looking for I1, I naught, I2, and V naught. Right. Okay. So these equations are for reference. So let's go ahead and solve for one. So I naught. The best way to approach this is to find the equivalent inductance between these two, right? So our equivalent inductance would look like this, right? So we got first inductor minus the mutual inductance plus 1 over the second inductor minus the mutual inductance. And this would look like this. The factored form of this. Okay, so now that we know the mutual inductance and the inductance of each inductor, so we're going to go ahead and plug that in. So it's going to be 5 times 10 minus 5 squared over 5 plus 10 plus 2 times 5. 50 minus 25, 25 over 15 plus 10, 25. So we got 1 Henry. Okay, so then we can go ahead and with this value, we can find our tau because we only have one resistor. So this is our equivalent resistance. So then we can find tau. So tau is going to be equal to 1 over 20, right? Okay, so now that we have our tau, and we know that I naught at time before 0 is going to be 0, what is going to be our I naught at time 0 and our I naught at time infinity? Or might as well just say our, yeah, or I naught at time infinity. Just to clarify this. So our I naught at time infinity, we can just go ahead and divide 80 and 20. 80 divided by 20 is going to be our current across across the resistor. So it's going to be 4 amps, right? And then we're going to apply our formula. So go ahead and say IT is equal to I infinity, which is 4, plus I at time equals 0 is going to be 0, minus 4 I infinity times e to the negative t over 1 over 20, and that's going to look like this. Right, so, oh, forgot to say I naught. So this is going to be our equation for I naught at time greater, equal or greater than 0. Okay, so let's move again. Let me copy and paste this. Right, so now we want to find 2 V naught T, right? V naught T, if we look at these equations, the most appropriate equation to pick would be the second one here. So let's write it down. So circuit analysis, I naught T equals 80 minus V naught T over 20. And go ahead and simplify this and say 4 divided by V naught T over 20, right? So once that, we can go ahead and turn everything onto the left side and leave V naught simplified. So then we would have well, let's not do that actually. Let's not factor this. Say 20 I naught T. So this is what our V naught T would look like. So then what we would have to do from there would just be plug in I naught t into here. So 80 minus 20 times 4 minus 4e to the negative t20t. We get 80 minus 80 plus 80 e to the negative 20t. So then or v naught t for time greater than 0 would be 80 e to the negative 20t. These two get simplified. All right. Let's move on. So we got C now. So let me copy and paste this. Right. Okay. So so I1 T. We can go ahead and look at the KCL for this. I naught equals I1 plus I2. So if we take the derivative, we know what I naught is, right? So if we take the derivative of I naught equals to the derivative di1 dt plus di2 dt. We know that I naught is equal to 4 minus 4 e to the negative 20t di naught dt equal to 80 e to the negative 20t. Okay. So then what can we do with this? So essentially what we can do with this is we can go ahead and say, we can play with these equations now. So we can say 80 e to the negative 20t equals di1 dt plus di2 dt, right? And so let's see, 80. So, okay. From these two equations, you can say do 2 v naught t equals to 5 di2 t over dt, right? So plug that in. So say di2 t is equal to or actually, yeah, we can deduce, we can say that about this Let me think. Okay. So then we can go ahead and plug this back into this. So 80e to negative 20t equals, or not back into this, then back into this. Oh, here's the highlighter. There, back into this equation right here. You can go to, there's two ways to go about it. You can solve for this one or this one. So 80e to negative t, 5, just make them a function of one of these unknown constants or variables. Sorry. Yeah, so 5 di1 dt over t minus 5 80e to negative 20t minus di1 t over dt. Okay. It's going to be 80e to negative 20t plus 5 di1 t over dt minus 400 negative 20t plus 5 di1 t dt. Okay. So then you can go ahead and say 480 e to negative 20t equals 10 di1 t over dt. And then di1 t over dt is equal to 48 e to negative 20t. We take the integral of di1 t over dt. Right. So then that would be 48 over negative 20 negative 20t. So then that would be, let me make more space. Yeah, it would be negative 48 over 20 e to negative 20t minus negative 48 over 20. This is t and this is 0, and then that would be 48 over 20 minus 48 over 20 e to negative 20t. Okay. And that would be our I1t. Actually, I1t. It's asking for I2, right? Right. That's what it's saying. Yeah, I2. So to find I2, we can either go through this whole process again, or we can just use this KCL where we know the value of I naught, I1. So then we can say I2 is I naught minus I1, and I naught is 80, or no, it's 4e to the negative of 4. So it's 4 minus 4e to the negative 20t minus 48 over 20 minus 48 over 20 e to the negative 20t. And we simplify these values. 40 over 2.6. So 48 over 20 is 2.6. 1 point, is it? No, 2.4, sorry. So it's 1.6 minus 1.6 e to the negative 20t. And this would be